Okay, we're looking at just solving quadratics by square rooting. This is just again a technique trying to figure out and solve equations that are quadratics, but by square rooting. This is something you guys have done before. We're just gonna go over this again and make sure you guys are good with this. So, all right. So if I look, both these two that are on my paper, they are quadratics because they have a squared term with them. What we mean by square rooting is once I get the squared term all by itself, the only way to get rid of the square is to square root. And so what I will do is just take and again just square root that. And I have to do that to both sides. What that does is it gets rid of this square right here, so I'm left with x. And then I take the square root of 144. When I break that down, again, you do your number prison here, but this is a perfect square, so this is going to give you 12. The only thing you guys got to remember, though, is we're always going to have a positive 12, and we're going to have a negative 12. So with every one of these problems, we're going to have two answers that'll make this correct. Because if I square 12, it'll give me 144, and if I square negative 12, it'll give me 144. And so my two solutions here are just positive 12 and negative 12 for this. So you can't forget that once you get your answer, you have a positive and a negative of those. Okay. If I look at the second example, I have to get the squared term by itself. Like I have to get this x squared by itself. So to do that, I'm going to add the 64 over to start with. And then I have this x squared equals 64 here. And then now I can use my square roots. Okay. And I'll be left with x here. And then this is another one you do number prison on this. This will give you 8. And I have also negative 8. Okay, sometimes you'll see this written as like x plus or minus 8. So they have this plus or minus, so you don't have to write 8 twice. But it's just saying the same thing right here that we're talking about right there. So, okay, so we isolate the squared term and then use square roots and then just simplify after that, okay? So if I look at a couple of these other examples, we're going to isolate the square root, the squared term. So I need to get this x squared by itself. So that means I've got to divide by 2 to start with, which just will give me x squared equals 16. And then I'm going to square root. And that'll give me x equals 4 and negative 4. So I have both of those values there. I put one with fractions in there just to give you guys a little bit different look here. Guys, get rid of this fraction. I'm going to times by 2 because that'll just give me 1x squared on this side. So I do need to times by 2 over here. When I times by 2 there, it's going to give me 60. And then I square root. And so I get x equals, this one is not a perfect square, so I need to break this down here. 3 and 2, 2 and 5. So I've got a group there. 1 is gone. So that means I'm going to have 2 square roots of 15 here. And then I always have to have a second one, so I have negative 2 square roots of 15. Or again, you could write that as plus or minus 2 square roots of 15. You can put it either way. It works pretty good either way that way. So, all right, so that one's a little bit different because we had to actually, we didn't have a perfect square. We had to actually simplify that one. So, okay, looking at some other variations. These are some of the other variations where we've got something in parentheses, but our idea is still the same. We're going to isolate the squared term, which the squared term is everything in this parentheses. So I need to move this 3 and I need to move this negative 9. Okay, and so we're going to work backwards from order of operations. We're going to actually move the adding, subtracting 9 here. So we're going to add 9 here. So that'll give me 3, and then x plus 2 squared equals 9. Then I'm going to divide by 3. And then I'll have x plus 2 squared equals 3 here. And then I'll square root, because now I've got my squared term by itself. Okay, so I don't square until I've got that by itself. What that does is it gives me x plus 2. It gets rid of my squared in my parentheses essentially. And then I'm just going to put positive and negative square root of 3, but really that's positive square root of 3 and negative square root of 3. This doesn't simplify any, so we leave it like that. And then I do need to get x by itself because that's my goal here, so I'm going to minus 2. And so I'll be left with x equals negative 2 plus or minus the square root of 3, which again, you could plug that in your calculator and you can get 2 different values in that. Matter of fact, if you go negative 2 plus the square root of 3, that's going to give you approximately like negative 0.268. And then if I go the other way where I subtract it, I'm going to get negative 3.732. So I'm actually a-okay with you leaving it as this exact number, but just so you know, those are actually your solutions too. Those are just rounded values, is what it is. Okay. They just don't come out as whole numbers, and that's okay. They come out as irrational numbers, and that's not a problem. So you can leave it like this, or you could write it out 2 separate ways. You could write it as negative 2 plus the square root of 3, and then negative 2 minus the square root of 3 would be my 2 answers. Again, which gives me these other 2 decimal answers down here. Okay, this one to the right, if we do that one, this one's nice. I just need to move the 3 first. So I'm going to divide that by 3, and that will give me x minus 5 squared, and then that is equal to 15. Wait, sorry, 25, my bad. Got thinking the wrong way here. So I've got 25 here. And then I'm going to take the square root now because my squared term is isolated, so this will be x minus 5. And then this will be plus and minus 5, because this one simplifies nicely to 5 there. And then the last thing I'm going to do is add this 5 over. And this one makes it nicer. It gives me some actual whole numbers here. So I'm going to have 5 plus 5, which will give me 10. And then I'll have negative 5 plus 5, which gives me 0. So my 2 solutions that I get for that one are 0 and 10. So again, all I did to get those 2, I went positive 5 plus 5, and then I went negative 5 plus 5. Just like we did down here. These just came out as irrational numbers, okay? Okay, last example here. Sometimes we get imaginary solutions. So we'll do this one here. It's the same idea. I'm going to get rid of the 14 first. So I have to minus this 14. And I'll be left with this x minus 6 squared equals negative 64. Okay, so now my squared term is by itself, so I'm going to square root now because of these parentheses. And this will give me x minus 6 equals, when I go to simplify this, this will give me negative 1 and 64. And then 8 and 8, 4 and 2, and then 2 and 2, 2 and 2. I got a group there, I got a group there, and I've got a group there. These are all gone, which will give me 2 times 2 times 2, which will give me 8. And then I have this negative 1, which becomes I on the outside, if you guys remember. And then I do have, it is plus and minus as well. We can't forget that. Okay, and then the last thing I'm going to do is add this 6 over here. So I'll have x equals, we'll go 6 plus 8i, and then we'll have 6 minus 8i. Those would be my 2 solutions. Again, you can write it like that, or if you want to write it as x equals 6 plus minus 8i, that's probably the way you'll see it most of the time, because we like to shorthand things. So, all right, so there's your different variations of solving by square rooting. The process is still pretty similar. You just get the square term by itself, then you square root, and then just simplify it from there. So, all right, this has been your math moment with Mummy. Bye.